Question number 29. It reads a container of mass capital M, which is 10 kg, containing mass small m, which is 1 kg of an ideal gas. And this is released without initial velocity from a height h0, which is 12.1 meter. If the collision of the container with the ground is perfectly elastic, how high above the ground will the container bounce? We need to neglect air resistance, and we need to assume that all the internal fluctuations in the gas damped out almost in no time. Gravitational acceleration is given to us 10 meter per second square. So let's consider the solution. Now this container is filled with the gas and it has been released from certain height, which is h0. When it comes down, then it will get a velocity. Let's say that velocity is v0. This v0 can be written as under root 2g h0, simply using the kinematics. Now, since the collision is perfectly elastic, so you'll find when this box is going to collide with this ground, the figure that is not made over here. So just before the collision, velocity of the box or this container will be downward as under root 2g h0. And the velocity of gas particle will also be the same, that is under root 2g h0. But when the collision is taking place, the collision will be between the ground and the container. And these gas molecules will not participate at that instant. So due to elastic collision, we will find that the velocity of separation will be the same as the velocity of approach. That means container will immediately start moving up with velocity v0, which is under root 2g h0. However, just after the collision, you'll find the particles of the gas will still be moving downward with velocity v0. Then after, what will happen, these gas molecules will collide with the bottom of the container and then they will bounce back. And since this happens in no time, so we will say that this container has not gone much distance from the ground then. So this figure is just after the collision, and this figure is just little later when the gas molecules damped out whatever these fluctuations were. Then after, you'll find whatever the velocity of gas particles got upwards, the same velocity the container will get, because there's going to be internal forces acting, and that there will be momentum conservation between these two situations. And this will be the final velocity of the system, and this velocity will decide how high it is going to go, and that's height we need to find out. Now if we try to solve this height, then we say that if the height of bounce is small h, let's consider that is small h, then we can say this velocity is going to decide that is small h. That means v is equal to under root 2gh. So from here we can find out h if we know the v. To get this v, what we are going to do, we are going to consider these two situations. One is just immediately after the collision, and another is just little later. That means there's almost no time gap. So here we can go for the conservation of momentum. Why? Because we consider the system. So gas and container, they are single system, and gas molecules are colliding with this container wall. So whatever these impulse forces are going to be, they are going to be internal. So going for the linear momentum conservation with this and this situation, you'll find the initial linear momentum was capital M v0 upward, small m v0 downward. So m v0 minus small m v0 is equal to, finally both are moving upward with speed v, so capital MV plus small mv. From here the v came out to be capital M minus small m divided by capital M plus small m v0. Now v0 was under root 2gh0, so we can place it as under root 2gh0, and v is under root 2gs, so we can substitute as under root 2gs. We can square this both side, then 2g will get cancelled out. H is going to be equal to m minus small m divided by capital M plus small m whole square into h0. So that becomes the expression of the height up to which this entire system is going to rise up. And now we can put the values. h0 is 12.1 and m is 10, small m is 1. So this is like 10 minus 1, which is 9, 10 plus 1, which is 11, square of it. So it's like 9 by 11 square, which is 81 by 121 into 12.1. So 121 and 12.1 will get cancelled out, and 1 by 10 will be there. So it's like 81 divided by 10, which is 8.1. So the max, the height up to which this entire system is going to rise is going to be 8.1 meter. This is going to be our final response. That's all. Thank you.